Hi, we're going to have a panel discussion with the three teams that are presented in the first session. So while preparing for panel talk, this is AJ, founder of Radius. This actual conference was the second that our team organized. Last year we did ZK Night at the time, Anoma, and then other great project also joined, and then this scaling thing also great projects joined, and then thanks so much for sponsoring and coming by to present your project. So Adrian and Brian, Ariel, please come to the stage. So this one. So actually I prepared a couple of questions, but I'm open to you. If you have questions, please raise your hand, and then you can ask them any questions, because these three projects are really great, and then you cannot see all of them in one stage that many times. So anyway, thanks for coming and joining this event. I will start with general questions. So all of us here are trying to scale blockchains in different ways, like Starkware through layer 2, ZK Stark rollups, and then Mina, you built a recursive ZK based layer 1, and then Anoma, you have a multi-chain approach with intents. So I want to ask you that why did each of you choose this architecture, and how do you think that the community is taking your approaches?
All right, this works. I think we've taken a very different approach with scaling because people have been asking a different question than we have. It's like every existing scaling solution really is about the idea on how do you scale a single homogeneous security model, right? So like we want to have one global Ethereum layer and, for example, or one global Mina layer, and we want to have many things hang off the security model and be secured by this global consensus. And this leads to very different design decisions. And sort of we've taken more the approach on, we don't want this, we want to have homogeneous architectures, but heterogeneous security models. So that, and which to some extent becomes easier to scale, because you can say, well, the local village can run its own blockchain as long as they're happy with it, right? As long as they're happy with the security model, but users and assets can flow very freely between these many different systems. And one of the best parts actually about Anoma here is that I, as a user, I can issue an intent that is settleable somewhere. So I never have to worry like which specific blockchain to interact with. I can say things like, I want to be settled on Ethereum or on Starkware or on Mina in my intents. And then then solvers actually have to do the hard work of figuring out how to move these assets along whatever path exists in order to move the assets. I think our approach is probably the newest, as people are slowly starting to come around with regards to intents. But I think once people really start to understand the model and what it fundamentally changes, they generally get quite excited about it.
Thank you. No. Yeah, perfect. Thank you. Hello. Yeah, that's better. Yeah, so I mean, there's many ways to think about scaling. I mean, everybody goes back to TPS always, but it's not just really about TPS. Like we want to scale the amount of computation that can be compressed and then processed by a blockchain. And Mina's approach was like, okay, let's start from first principles and build a blockchain that's really, really good at processing zero knowledge proofs. So like the first use case for processing those zero knowledge proofs is this succinct blockchain notion, right? And that kind of solves, there's a time and space problem, and that solves the space problem because the blockchain remains succinct. So the really large, like full node bloated blockchain problem is solved, but it doesn't necessarily solve the time problem. So for Mina, I think the road to really solving like high throughput, low latency is to use the fact that we've created like a really solid base layer for process and zero knowledge proofs, and build the roll-up infrastructure on top of Mina to get like the really, really high TPS numbers that like we all need. With that, on the application side with recursion is like on the base layer that gives us a sync blockchain, but it's also like available to application developers who can, you know, build proofs inside of proofs inside of proofs inside of proofs that settle back to the blockchain. So like not every proof needs to go to the blockchain. Like we can have a series of proofs which all relate to each other. This could be something like a ZK game, for example, where, you know, there's like X participants, there's N number of turns, and each turn, like the proof is generated of the previous go, and everybody knows what exactly has happened in the path, but that only needs to get settled to the blockchain in the last proof, which contains everything that happened before. Yeah, so in short, to answer the question, like our approach has been ZK first, and that's going to be extended out into the roll-up ecosystem as well as interoperability, again, using like state-proof bridging.
I guess this works. Yeah, great. I'll just leave it here. So why L2? So one reason is that with a validity rollup, we can actually leverage the security of L1. If we're happy about the decentralization properties of L1, we can improve its TPS, which is one of our primary goals, through proofs. So we can bring proofs to an existing layer 1 and use the current diverse validator set and the security guarantees. Another related reason to this approach is that it basically allows us to focus on what we're best at, which is designing proof systems and innovating in that area. And being an L2 allows you sometimes to make relaxing assumptions. So for L1, they have to solve core consensus problems. They have to guarantee consistency and liveness. And decentralized L2s also have these challenges, but there are some relaxing assumptions that you can make. A very simple example is that if we're thinking about, when designing Starknet's decentralized protocol, censorship resistance for the sequencer level, then the current design is to have the stake managed on L1, on an L1 contract, and joining and leaving the staking pool is done through an L1 transaction. And if you assume that L1 has certain good properties, then you are less worried about this. So it helps with the assumptions that you can make and lets you focus on the proving side.
Okay, so okay. So it's my personal question, but many of us actually thought that like a couple of years ago, that scaling was solved when like a plasma was proposed, but it's been still scaling thing is ongoing. So just I was curious that what do you think is the end game of this scaling solution?
I mean, to be fair, I will sound biased. I think the end game of scaling is going to be intense, mostly because they also represent in the correct way what users on L2s actually do. This is less to say where these protocols get deployed to, because that should fundamentally be a user choice in terms of what security model they care about. But I think sort of the end game is going to be intense. I think you mentioned plasma, and especially on the optimistic side, on the optimistic rollup side, I'm pretty skeptical that this can work long term. Mostly because we've been trying for a couple of years, and like we had payment channels working on Spank Chain in like 2018, but they never really got traction because they're just like fundamentally hard to run. Because if you actually want to have a decentralized L2, at some point in time, you're almost going to have to run your own consensus in order to select your decentralized sequencer set. So I think a lot of these problems are going to end up coming back to, we're going to have to run many different blockchains, or in many different security models, but they need to be interoperable with each other. I think this entire notion that everything should be checkpointed and scalable in a single worldwide security model seems very unlikely to play out in practice. Not only because I think it's technically incredibly difficult, but also because it's socially incredibly weird, because it's sort of saying the same as, well, we all want to live in a one world government kind of world where there's one global consensus provider that we all checkpoint into. And this just like seems game theoretically incredibly unstable, because you can't, like if you have faults on the one true security model, where do you exit to? So I think, so the safer model is we have many different security models people pick independently, but these security models can interact with each other at will.
Endgame. There's a little roadmap item on the Ethereum roadmap called ZK Everything. So I know I'm biased in this direction, but yeah, I do think like once Ethereum pivoted to the rollup centric scaling, that kicked off a wave of innovation that like hasn't really finished yet. Like we're in the optimistic phase of this now, but we haven't really progressed where, as Adrian says, like none of these sequencers are decentralized. You need to trust like a central server operator basically to settle your transactions. There's the whole optimistic thing, which I also think will be phased out in the end. And yeah, like I do think that these rollups will have their own consensus, and there should be some way for the user to choose which settlement layer that they want to go down to. And I think ZK helps with that as well, because with ZK bridging, and we'll probably talk about bridging later, but yeah, my answer is ZK rollups and like L3s, L4s, all of these things recursively composing with each other on other chains actually.
Yeah, I'll just start by saying that I very much connect with Adrian's point from before. I think one consensus supplier is a nightmare and not something that is desirable socially. Where do I see the end game? Obviously, I'm also biased, and I'm also looking strongly at the ZK rollups or validity rollup space. So to me, I think that fully decentralized validity rollup, and that has a more precise meaning that we can unwrap, but figuring out how the consensus protocol for a validity rollup changes compared to L1, where exactly proofs get involved. And in that area, Mina actually innovated a lot, and were actually inspired by some of the ideas there when thinking about how to include Starknet proofs throughout block production. So I think that's one of the biggest things. A decentralized rollup obviously implemented, and there are also other challenges specifically in the areas of adoption, because even if we solve scalability and we can run much higher TPS, and we've reduced costs through data availability solutions and through proofs, there are still some significant problems with adoption, with wallet management. I think that's also a very significant challenge to bring blockchains to the masses. There's significant progress there, specifically with the world of account abstraction and sort of replicating Web2 experience. And I think that's also an important part of it.
I just add on to your point, actually. I think something I realized while you spoke is like the distinction between rollups and blockchains is going to go away. It's just going to be many different protocols deployed in different security models. This is, I think, sort of rollups are a fluke of the moment kind of thing. Like the distinction is going to disappear. And I think some of the harder challenges that most people aren't thinking about yet, it's actually not where the settlement happens, because the settlement you can use zero knowledge proofs to make quite efficient, or like efficient. The bigger problem is, where do these people like coordinate with? Like, where do these people, where how do the proofs get shipped around the network? They can be computed somewhere. This is, I think, sort of a very underexplored area. On the really discovery, like how do you ship around signed bytes of data that aren't completely settable yet somewhere before they end up at someone that either does a proof on them or combines them with other people's intents. This is, I think, the really big chance that's going to go forward.
Okay, so in the audience.
Yep. I want to ask to Anoma. So, I think changes at the protocol level must be important, and I also think the changes at the application level is also important. So my question is like, what is the any plans to any tools for application developer, and what do you think the benefits of building application as intent-centric application instead of transaction-centric application?
Yes, this works great. So the question on like what are the benefits for developers of applications with regard having intents rather than transactions, specifically with regards to zero knowledge. So the application has to do less and can be more general because the application just does verification, as in you don't have to encode specific rules because they can sort of be supplied at runtime by the intent. So this makes the application design somewhat simpler. The other nice thing is that you, as a sort of from a high level as an application developer, you don't have to worry about running the backend services to make things like OpenSea work, right? Because like for OpenSea, there's a bunch of Web 2 services in the background that make the application actually work. With intents and something like Anoma, you just get these things for free in the same sense that you got sort of programmable settlement for free on Ethereum in comparison to something like Bitcoin. Specifically with regards to zero knowledge proofs, one of the really big benefits of intents is if you want to do privacy preserving applications. One of the challenges is how do you write a privacy preserving application? Because someone needs to generate the proof, and that prover generally needs to have access to all the private inputs. So in most models, we end up in like some prover runs in some trusted execution environment, where like, for example, there's a TEE running some solving, some matchmaking, and everyone streams the orders against this, and only the solver sort of gets the view into what kind of trades are happening. This is not a great model because obviously you're leaking data to a central party, even though you can pick your central party yourself. So with intents, users can attach proofs for authorization. So the who is private, but the what is public. This way, anyone in the ecosystem can run a solver and solve against this. And then even as a user, you can also say, well, I only want to send my specific intent to these 3 nodes, and then these 3 solvers can sort of do partial solves. So I think sort of especially if you want to have privacy preserving applications, there is a massive benefit to using intents because it sort of helps you a little bit with the problem of how do you gossip around private data, private state. If you like that kind of stuff, check out Vampire and Juvix, which will also be usable to write circuits for other systems outside of Anoma. It's a cool language stack. Thanks.
So as for the application side, Mina and Starkware also has their own languages, so Cairo and Snark.js as well. So I just want to ask that what does the current status of your developer ecosystem look like? And then isn't it too difficult to learn for developers?
Well, the rationale was that a lot of developers know TypeScript already, but they don't know how to write zero-knowledge circuits. So what the intent was to, tie these two things together, such that a developer who knew TypeScript, who could understand how blockchains work, and who could also understand like the abstractions of the circuit below, didn't have to get like down deep into the hardcore circuitry of the thing. And yeah, it's going pretty well. We have really good feedback. As I mentioned, we're running the ZK Ignite cohorts, and we're at cohort 2 now. So there's been hundreds of developers through those, and they're starting to build really cool things. Yeah, so I mean, I think the original intent was to make ZK as accessible as possible for as many developers as possible.
Yes, so the intent with Cairo was, again, targeting proven efficiency. I wanted to design the VM with the intention of being efficient to prove. And over that, we've developed the higher level languages, Cairo 0 and now Cairo 1. So with Cairo 0, the situation was more difficult. It was a lower level language. People did not get what they are used to get, I don't know, with Rust, for example. But still, many developers surprised us and developed significant business logic with Cairo 0. Now with Cairo 1, when the language is much more like Rust, I think we're getting the best of both worlds. We'll still have this proving efficiency, but now the language is much more modern. And in regards to where is the community at, so currently it's at an interesting point due to the split between Cairo 0 and Cairo 1. But now with our support, we see a lot of applications starting to migrate and work and really see the benefit of the new language. But yeah, we're now a long way, even in Cairo 0, that was the situation, but we're a long way from writing raw algebraic stuff or circuits in order to generate proofs.
Just super quickly, with Juvix, I think Juvix was specifically designed so that as a developer, you didn't have to think about what a field element is anymore. And I think we're very much getting there. And so the cool thing is you can actually write an application in Juvix and then later on decide which proof system you want. Because it goes Juvix to Vampire to specific proof system. Currently, Vampire supports Plonky and Halo 2, but there's also a Stark backend in the work, and sort of like you can just add more proof systems into the backend IR, which is Vampire. Vampire really is like LLVM, but for proofs. And so in the future, like the cool thing is you write an application once, and if in the future there's a cool proof system and you want to target that proof system, as long as one person has built a backend, your application without having to be rewritten can target that new proof system. So yeah, that's sort of the state there. We have a couple of hundred developers actively on the Discord developing cool stuff. So it's definitely usable, has great documentation. So check it out.
Okay, great. So we are running out of time. So my last question would be about the composability. So how do you envision interoperability between different blockchains? Because some people say that many projects actually don't care about this composability because this kind of market is winner takes all. So do you have any solutions you are working on to support this interoperability?
It's called, you have to think of the space for interoperability, as in you can have IBC here, which is the most decentralized thing you can do. And then you can have a single key bridge. That's sort of the most centralized thing you can do. You can't do better than IBC and you can't do worse than the single key. Whatever bridging solution people sell you is somewhere on the spectrum. Generally speaking, the further you go towards a centralized system, the more money people can charge. Like IBC doesn't charge you money. It's just like proof carrying data between chains. There's no business model here really to like just build IBC. If you run a single key bridge, there's lots of money to be made because you control all the funds in the bridge. It's like, it's a great position to be in if people trust you, right? This is sort of the important thing to understand. And I think most blockchains, most decentralized systems, especially systems that run BFT consensus, are going to gravitate towards this IBC end of the spectrum because it's easy to do once you have BFT under the hood anyway. The dev UX gets a little bit like you can make better dev UX if you have more centralized systems, but again, they're more centralized. So like you as a developer, you have to pick what your trade-off spectrum is like. Do you care about decentralization? Do you care about dev UX? And this is sort of how you move along this line. But you can't go beyond either of the endpoints of this line. There's like IBC is sort of what is at the limit of distributed systems design and speed of light communication. Single key things are sort of as the most centralized about best UX you can do.
Thanks. Yeah, so Mina's approach is again like using ZK because we have a sync proof of the state of the chain. And we actually have a team called Nil Foundation who were granted from ourselves and Ethereum Foundation to build a single way bridge from Mina to Ethereum using Mina state proof. So somebody generates Mina state proof, anybody can upload that into the EVM smart contract. And that smart contract will verify that it's A, a valid Mina state proof, and it's B, that's the latest and strongest Mina state proof according to the Mina consensus. So in practice, what that brings is that as an Ethereum developer, I can call this canonical Mina state contract that lives in the EVM, and I can look up some piece of account data on Mina. So if there's some private like voting application or some private thing that you want to do cheaply on Mina, you can do that quite easily from Ethereum or from other L1s. And I don't know, it's not really like a bridge, it's more like something else because there's not really any kind of like bridging happening in the traditional sense where one thing has been locked here and one thing has been locked on the other side and it's being transmitted that way. I know there are a bunch of teams working on state proofs for like Ethereum Light Client Network and Cosmos IBC and things like this. So, I mean, my opinion is that it's going to go in that direction for ZK bridging. And I'm hoping that Mina is going to be the first production ZK bridge that's going to come out. But yeah, I think there's a Starkware ZK bridge coming as well, is there?
Yeah, we have Stargate, which makes use of our native L1 to L2 bridge. But before I get into that, I want to emphasize that I think we should focus on interchain interaction. What's interesting in the world of rollups is that once we solved the L1, L2 interaction with some sort of native bridge using the existing proof system, then this effort can be taken up by the community. Once you have L1 to L2 communication working naturally, you can have different teams picking it up and basically thinking on what trade-offs they want to focus on and implementing some more general bridge between more chains. To me, what I think the direction should be, or the bridges that seem most promising to me, is projects like you mentioned, which basically prove on chain 1 what happened on chain number 2. For example, by basically simulating a light client, verifying a proof, attesting to the consensus of chain 2 on chain 1. And that way you basically have a sort of trustless interaction between the chain. So I think this is the natural direction to go to. And yeah, our bridge is basically using our native L1 to L2 bridge, which is using star proofs.
Because I forgot to mention, it's important to, the ZK bridges are amazing and we should all be using ZK tech for bridging. This is something but like you can slot this into IBC effectively as like instead of doing a Merkle proof, you do a ZK proof and you use that to attach to attest to the consensus of the other side. So like there's lots of ways to sort of use ZK tech to make IBC better. Yeah, these are not orthogonal ideas. They're like very compatible, I think.
Okay. So thank you so much. This is the end of the panel talk, but the speakers will be around here, so you can approach them to talk about another things. So yep, we will have 10-minute breaks, and then after breaks, we'll have another second sessions. Thank you.